Now if you cross multiply, you get 3BC is equal to 3125, because root 3 into root 3 is 3. That means BC is 3125 by 3. So we have managed to find out the length of BC, and we know the entire length, this AC, as 3125. So therefore this length BC will be, in fact we have to find AB, this length. So therefore this length AC will be, hence distance between the two planes at the instant, hence distance between the two planes at the instant and at that particular time is equal to AC minus BC, which is 3125 minus 3125 divided by 3. So in order to simplify this, take 3125 common, you get 1 minus 1 by 3. So you get this as 3125, 3 minus 1 divided by 3, which is equal to 3125 into 2 divided by 3, which is 6250 divided by 3, which is 2083.33 meters. Or you can also write this as in mixed in terms of mixed fraction, 2083 1 by 3 meters. Okay, so this was an easy one. In fact, you will have, as I told you, you will have marks for drawing the figure also. In this case, the figure was not given. So drawing the figure is the main thing. Once you draw the figure, then you can easily find, I mean, the solving the problem is not too difficult if you can understand the figure. Okay, and whatever problems I have solved in this notes, these are the only types of problem that will come in your ICSE. There are no other variations of this problem that you will find in the book. All other problems are related to the one that I have solved here only. You can take ideas from the notes in order to solve the problem that I have left. Next question is, this is another type of question which has come in your examination. And again, if the diagram is not given, if the diagram is given, you are lucky. But if the diagram, in most of the cases, the diagram is not given, how will you draw the diagram? For that, you will have to read the problem over and over again. At least 2 times you have to read the problem. So let us see. The question here is, the shadow of a vertical tower on a level ground increases by 10 meters when the altitude of the sun changes from 45 degree to 30 degree. Find the height of the tower. That too correct to 2 decimal places. Okay. The shadow of a vertical tower. Let us say this is our vertical tower. Let us try to understand how to draw the diagram. The shadow of a vertical tower. Let us take this as our vertical tower. Okay. On a level ground increases by 10 meters. Now, if this is the tower, okay, then the sun will be somewhere over here, right? This is the class 1 sun that I used to draw. Okay. The sun will be somewhere over here. So now the light source, whatever light is coming from the sun, it will come from here, right? So what happens? This will cast a shadow of this tower, say somewhere over here. Okay. It will cast a shadow, and now it is not necessary that the length of the shadow will be equal to length of the tower, right? While you are walking on the road, you see that your length of your shadow varies according to the light source, right? From depending on the distance of the light source that you have, or in fact not only on that, but also depending on whether light source is a point source or an elongated source. Okay, On that also your shadow depends. So there are a lot of things that shadow depend, but here mostly we are concerned with the length of the shadow. But the shadow here may not be equal to the length. That is what you know. So let's say that the initial shadow here is falling at D. Now what happens? The sun change either rises or either sets. Okay. So now what happens in the horizon? Suppose if the sun is going up, or even if it is going down, does not matter. Okay. Now what happens? This shadow that is falling, this becomes a little longer. Okay. Say the new shadow length is this. So from D, so if initially the length of the shadow was BD, okay. Now the length of the shadow has increased from this to this. That means if I call this B, if I call this A, so this becomes your tower, and the initial length of the shadow was BD, and after the sun changed the angle, now the length of the shadow becomes this BC. That is what the meaning of the problem is. Okay. Now what is given here is that the angle of the sun, the when the altitude of the sun changes from 45 degree to 30 degree. So altitude of the sun is changing from 45 degree to 30 degree. That means the sun is setting. Okay. So now what happens? That means this was our initial length of the shadow, and this is where the final shadow falls at the top of the tower. Okay. So angle of the sun changes from 45 degree to 30 degree. So if the angle of the sun changes from 45 degree to 30 degree, that means this angle must be the higher angle, 45 degree, and this must be our lower angle, 30 degree. You can also understand it in terms of angle of depression also, the angle that the sun is making with the horizontal. If that angle changes from 45 degree to 30 degree, you can also understand in terms of that. But I won't be concerned about the angle of depression. I will not bring an angle of in such a case when the angle of the sun is given to you. Then remember that whatever angle that the sun changes from, the higher angle will be the closer angle, but it's closer to the tower. The lower angle will be the distant angle. Okay, so that is what you must understand, that the higher angle will be the closer to the tower, and the lower angle will be the distant angle, far from the tower. Okay, so that is what, once you draw this figure, now we are going to answer our question. The question is find the height of the tower. Okay, consider, let the height of the tower be x. In this problem, normally, whenever, remember that if the height is not given, you will take the height as h. And also one more thing is given, that the shadow elongates by 10 meters. So this length is given to you. This length is given to you as 10 meters. The only length that is not given to you is BD. So let us take this length BD as x. Okay. So I start by saying, let the height of the tower be h and BD equal to x. This is what we start. So consider this right angle triangle first. This one is my 90 degree. So tan 45, we consider tan 45 is AB by BD. Because there are two angles given, that means I will have to consider two right angle triangles. First right angle triangle is ABD, which is tan 45 is equal to AB by BD. Now, tan 45 you know is 1, and AB is h and BD is x. That means h is equal to x. This is my first equation. Okay. Also, now consider the 30-degree angle. Tan 30 is equal to AB by BC. That means 1 by tan 30, is 1 by root 3. AB is h and BC is x plus 10, right? Because this length BD we have taken as x, and this length we know shadow elongates by 10 meters. So that means now cross multiply. That means h root 3 minus x is equal to 10. This is our second equation. Now we solve this first equation and second equation in order to get our value of h and x. But we don't need the value of x. We only need the value of h. Okay, and we know h is equal to x. So what we'll do is putting x is equal to h from 1 into, we get h root 3 minus x is equal to h, which is equal to 10. That means h times root 3 minus 1 is equal to 10. That means h is 10 by root 3 minus 1. Now because the denominator is irrational, we shall rationalize the denominator by multiplying by its conjugate. 10 times root 3 plus 1 into 10 times root 3 plus 1 to root 3 minus 1. So this is 10 should not be in the denominator. So 10 times root 3 plus 1 divided by 3 minus 1, which is 2. Okay. Now let us not cancel with 2. In fact, if we leave 2 in the denominator, it will become a little easier to calculate. So what we do is we just put the value of root 3 as 1.732. So this will be 10 into 2.732 divided by 2. This will become 27.32 divided by 2. Now we can easily write this as 13.666 meters, or 13.66 only. 13.66 meters. Correct to 2 decimal places. That was what they had said.
So it will be 13.67.
Correct to 2 decimal places. Let me just check once again. 21, 23, 626. No, 13.6. It will terminate. It will not continue. Because if you divide 27.32, because we have taken root 3 as an irrational number, that is in fact a rational number. Okay, that is why we are getting 13.67. Suppose if you take 1.732 and so on. Suppose if you take the value of root 3 till 4 or 6 decimal places, then you'll get more decimal figures. Okay, so we'll keep it at 13.66. You understood the difference? Why are we getting 13.66 and not 13.67?
Yes, sir.
Fine. So let us proceed with the next one. Number 5. A man observes the angle of elevation of the top of a building to be 30 degree. He walks towards it in a horizontal line through its base. On covering 60 meter, the angle of elevation changes to 60 degree. Find the height of the building correct to the nearest meter. Let us say this is our building. Okay. And see, the angle of elevation is mentioned. That means the observer is definitely at a depressed position and he's looking up. Okay. So the observer is looking up. Observer is looking at an elevated position. That is why the angle of elevation is given. So that is why let us assume that the observer is, say, somewhere over here. Say at C is our observer and this is our building, maybe. Okay. And he's observing the top of the tower. He finds the angle of elevation to be 30 degree. So from C, he finds the angle of elevation of the top of the tower. This is the horizontal. He finds the angle of elevation to be 30 degree. Okay. And now what he does is he starts walking towards the tower in a horizontal line. That is from C, he starts moving towards B. So he stops here. And then again he is observing the top of the tower. From C, say he reaches a position D and he's again observing the top of the tower. And now he observes the angle of elevation to be 60 degrees. So from here, this angle of elevation has changed. This has become 60 degree. Okay, and how much distance has he walked? He has walked 60 meters. So if you see, this diagram is very similar to this diagram, where here we had to find the height of the tower, where this length was given. And here if you see, we have to find the height of the building given this length. So the technique in both the cases will be the same. So let us consider the height of the building to be h. And let us consider this to be x. So I say let AB is equal to h and BD equal to x. That is, AB is the height of the building. So therefore, what is tan 60? Tan 60 is AB by BD. This will give me one relation between h and x. Tan 60 we know is root 3. AB we have assumed to be x and BD we have assumed to be x. So that means h is equal to x root 3. Say this is our first equation. We'll get the second equation with the help of the triangle ABC, the bigger triangle. So also tan 30 is equal to AB by BC. Tan 30 is 1 by root 3. AB is h and BC is x plus 60. X plus 60 is equal to h root 3. That means h root 3 minus x must be equal to 60. This is our second equation. Okay, so relation between h and x, this is one relation, and this equation number 1 here is our first relation. With the help of these two simultaneous equations, we are going to find out the value of h. We don't need x, we need h. Okay, so what you do is from 1, you find x in terms of h. From 1, x is equal to h by root 3. Okay, putting x is equal to h by root 3 from 1 in 2, we get h root 3 minus, put the value of x here. X we have found out from the first equation to be h by root 3 is equal to 60. Now we can solve for h. You take h common, you get root 3 minus 1 by root 3 equal to 60. H. Now what you do is take the LCM. Root 3 is your LCM. Here you will get root 3 into root 3 minus 1 is equal to 60. That means h times 3 minus 1 by root 3 is equal to 60. 2h by root 3 is equal to 60. That means h is equal to 60 root 3 divided by 2. That means 30 root 3. And root 3 is 1.73.
732.
Now if you just multiply this, you will get 51.96. And they have asked you correct to the nearest whole number, right? They are correct to the nearest meter. So once you have got 51.96, we can write this as equal to 52. We cannot actually write 51.96 equal to 52, but because we are writing 52 meters, we write this as correct to the nearest meter in brackets. Okay. So that is how you solve this. Now, both these problems were on almost of the same type. This one and this one, 4 and 5, almost of the same type, except that we had a shadow in problem number 4, and the shadow was changing the angles. In number 5, we had an observer here at C, and then he moved to D. So the angle of elevation changed. Okay. If you see in this question, the difference between this question and the next question is that there is no mention of angle of elevation or angle of depression here. Can you see any word here, elevation or depression? You cannot see in the problem any word elevation or depression. Therefore, when such a problem is given, you will judge by the angles. Remember, as I told you, always the lower angle, if two angles are given to you here, 45 degree and 30 degree, the lower angle will always be distant from the base of the tower. The higher angle will be closer to the tower. That is how you will judge. Otherwise, you will have to get into the angle of depression concept. Okay, this is a small shortcut that you can use here when the words angle of elevation and depression are not given. Let us see the next problem. From the top of a church spire, 46-meter high, the angle of depression of two vehicles on a road at the same level as the base of the spire and on the same side of it are x degree and y degree, where tan x degree is 1/4 and tan y degree is 1/7. Calculate the distance between the vehicles. Now there are two ways of doing, but this is more the way I have done in the notes is a better way because you don't have to refer to the tables in this method. Otherwise, you will have to refer to the tables, and you will get an approximate answer if you refer to the tables also. Let us try to understand this problem first. From the top of a church spire, let us draw this. This is a church spire, and from the top of a church spire, which is 46 meters high, this is 46 meters high. From that, this is our top. The angle of depression of two vehicles on the road at the same levels. This is our road. This bottom level, horizontal level, this is our road. Okay. Now you have two vehicles here. So you have one vehicle at C, and on the same level, you have another vehicle, say at D. At the same level of, at the base of the spire, and on the same side of it. Same side means one vehicle is here and the other vehicle is not here. No, then this is one side, this is the other side. It is not mentioned that one vehicle is here and the other vehicle is here. That means this would have been the opposite side of the church spire, right? Opposite side of the church spire. Otherwise, they have said that it is on the same side. That means it is on this side only or this side only. Okay, so that means both the vehicles C and D are on the same side. They are not on opposite sides of the church spire. So that is why we have assumed C and D to be here on this side. Or you can also assume on this side also C and D. But whatever side you assume, it has to be the same side because they are on the same side of the church spire. And you observe this to be, these angles are observed to be X and Y. Okay. These angles are observed to be X and Y, where tan of the angles are given, where tan X degree and tan Y degree are given to be 1/4 and 1/7. You will have to calculate the distance between the vehicles. What do you mean by distance between the vehicles? This is the distance between the vehicles. Okay. This is the distance that you will have to calculate. So if you now see, if you now compare this problem with this problem, if you see here, we did not know the height of the building, but we knew this length, right? Diagram is very similar. If you see this problem, we know this height and we don't know this length. Okay, so this is just the converse. So number 6 is the converse of 4 and 5. Okay, now how to determine which one is X, which angle is X, which angle is Y, that I'll be explaining in the next class. Okay, so I stop here for today.